Of course, there's more questions this time. All right.
$15 questions this time, huh?
All right.
Do we have everybody? Yeah, we do. We got everybody, right?
Yeah. Mm-hmm. All right. So does anybody have any questions on
I think we can kind of talk about them as we go through the quiz. I think there'll be some that we'll have to discuss, but.
Okay. All right. So question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of a z-score of 1.358 and to the left, negative 1.358. I got 0.75175, sorry.
Left of that, so you got 0.0872. Is that what everybody else got?
I got 0.0175 because you're doing to the right and left of the negative. You're doing to the left of the negative z-score and the right of the positive.
Well, it says to the right and the, okay, gotcha. I missed that. Sorry. So 0.1745, right?
Yeah.
Yes. So it'll be 0.175.
Yes.
Mm-hmm.
Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, or whatever the heck that symbol is. The distribution of the sample means is that symbol. I always forget what they are. This cannot be determined from the information given or no answer text provided. Okay.
This is one I had a hard time with because the standard deviation gets smaller as the mean and the population amount are further apart from each other, right?
Right, but you determine you determine the standard deviation of the sample means by dividing it by the square root of the population, right? The sample, right? So
This
theory that would be smaller, right?
Yeah, because it'll be 3.
Because if you have, say, a standard deviation of 3 in the individual observations, and then you take that standard deviation and divide it by the square root of 9, it would get smaller, right?
So it's the distribution of the individual observations, right?
The smaller standard deviation would be the distribution of sample means, right? Because you're dividing it by the square root of the sample, whereas the standard deviation of the sample is just the standard deviation of the sample.
Okay, yeah, that makes sense. Yeah, I got you.
Yeah, I follow you. So then which of the following results implies that the spread in, that's the spread in the sample? Is that what that is?
what is that symbol?
Spread in the population, is that an X?
I
Yeah,
have a hard time too. Like even writing my notes, I'm trying to write notes. I'm like, how do I do that symbol? How do I get that? Where is it?
It's not the sample size. It's got to be the spread in the distribution of sample means. So which of the following results implies that the spread in the distribution of sample means decreases as the sample size increases?
Hmm.
It's a good question.
Well, that's the X with the line over it.
Isn't so that symbol just means a value, right?
Well, I'm
Well, that isn't that the. Oh yeah, it says random variable. Okay, yeah. So with that formula, that's standard deviation of the random variable X is over the square root of. Oh my goodness. Sample size. Standard deviation over sample size. Square root of sample size.
I just love theory questions.
Yeah. What results implies that the spread of the randoms decreases. That'd be the law of large numbers, wouldn't it? No, the centrum theory.
I think it's got to be the law of large numbers.
Well, the law of large numbers isn't that just the larger the number it gets, the closer your mean is to the actual number, right?
Yeah, but the
Right.
closer the mean is to the actual number, then the further the mean is from the actual number, the smaller the standard deviation is. I really don't know. These two things confuse me super bad.
Yeah, I don't think it's law of large numbers in this particular case. I think it'd be which of the following implies that the spread in the random number decreases as the sample size increases.
It's got to be the central limit theorem, right?
Yeah, that's what I'm thinking.
That's what I'm thinking
That's
too.
dictating the closer that something is to. I can't remember.
Yeah, the larger the sample size, the less spread out the whole bell curve is, right? Because
Right.
it gets closer
Yeah.
to that bell theory. So
Everything
that
gets more compact.
yeah,
Okay, let's go with that. We've got 2 tries, so
yeah.
All right.
use the following information
Okay,
to
here we
answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with mean of 150.8 and standard deviation of 8.8. So the first question, Diane scores a 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score?
Okay, so she scores 160. Our
So,
mean is 150.8, right?
yep,
Right.
Their standard deviation is 8.8.
yep,
I got 1.045.
that's what I got too.
What was that again?
1.0, I guess it'd be 4.5. Yeah, 4.5. It does ask for 3 decimal spots. 1.045. And I'm so glad we can use Excel in this. My wife was telling me because when she was going through this, they couldn't use Excel or anything back in the day. Back in the late 90s when she was took this class. Was it late 90s that you would have taken it? 98, 90, 99, 2000? Around 2000. Okay, number 7. What is the probability that a randomly selected student will score above 160 on the quantitative report of the GRE?
So that's to the right of 1.045 on the applet.
Yep.
Mhm.
I got
Applets.
0.148.
Sorry, what was it?
I got 0.148.
148.
Mhm.
Yep, that's correct.
Okay. a random sample of 5 students was selected to take GRE. Their scores are 160, 175, 163, 149, 153. What is the z-scores corresponding to the sample mean of these students' scores?
Okay, so we got to get the average, right?
Right.
Yep.
which is the 160.
Oh, okay.
So it should be the same as the question 6. Or am I wrong?
I think yeah, you're right. I just double checked your math. I got 160 as well.
Yeah.
Right.
Okay, question 9 is where I start getting really thrown
Wait,
off.
hold on just a split second on that one here. No, this got to be, okay, sorry, you're right. Okay, sorry. Go ahead.
No, I was just saying question 9 with these probabilities is where I get confused because I tried the sample problem several times and I kept getting it wrong for some reason. So this might be where I need a little help. But
We got a sample size of 5. What was our standard deviation on that one? 8.8, right?
yeah,
Yes. Mm-hmm.
Should this be, what's the random variable? Is our standard deviation of the sample mean? Okay, that's, sorry. I was just looking at my Excel sheet and just thinking out loud. I'm sorry. 596 is a mean score.
Thank goodness. Cassie's gonna come over soon too.
Oh, it's 5. Okay, let's see your means, which is 3.93548. Standard deviation was 8.8, right?
Yes.
So we got a z-score of 0.1209, so I guess 1.121. And they want to know if we're lesser or greater. Let's see here. Greater than. So we would plug that in and look to the right. Isn't that what we would do? Because what I did, sorry, I was just kind of speaking loud. So I did I took the standard deviation, and then our sample size, it was 5 from our original amount, right? So our standard deviation from a sample mean was 3.935. And then we go over to that other formula that we plug it into. Our random variable would be 5 because they're asking about what 5 people, right, would be greater. The mean of the normal distribution random value is the 3.935, whatever that was, the standard deviation of 8.8. And then that gives me a z-score of 0.1209. And then we just have to look on the right side of that number, right? Am I doing that right?
Yeah.
There it is.
Yeah, that sounds right.
Yeah, let me.
So what did you get as your Z?
0.121.
So are you doing the square root of 5?
What was that?
So did you do the square root of 5 on that?
Yeah, I believe. Well, hold on a second. Let me check my calculations, how I had the math working on that. Yeah, so yeah, I did the square root of 5. So I did a standard deviation of 8.8 divided by the square root of 5 to get the 3.93548.
Okay, that's what I got.
And then the other formula that they give us is the one where we probability that a random variable will have a value greater than, in this case, random variable, which is 5 in this case, right? Because we're talking about 5 random students, right?
Yeah.
And then the mean of the normally distributed random variable, that was the 3.9358, that number we calculated before. Standard deviation is 8, so we take the oh goodness, my math here. blue. The random variable minus the mean of the normally distributed random variable divided by the standard deviation. And that gets me the z value of 0.121, which would be a z-score, and we're looking for greater than, so we look to the right of that z-score, right?
Yeah, so I'm having no problem getting the square root. I guess where I'm getting lost is doing the top part. Because you're supposed to do all of something divided by the standard deviation divided by the square root, right?
Yeah, the sample standard deviation. The standard deviation of the sample, isn't it? I have to check my notes. Hold on a second here. Okay, let's see here.
Value subtract.
Because I had this separated out in my Excel sheet that when I was setting up these formulas. I have these set up as two formulas as opposed to one. That's probably where I might be confusing somebody.
Yeah, I mean, that's where I'm confused because it says define the probability in the book. You take that X with the line above it, which is your population or your
Right.
p-value, right?
And minus the
mean all over the standard deviation divided by the square root of the number of the sample.
Yeah. So when I was walking through it, I did the bottom part first.
Okay.
And then that last part that I did would be the top part. And then obviously divided. Maybe I should share my screen with you and show you what I got.
I just want to see what you're getting as your top number after your math, because I think I can get the bottom.
Yeah.
And I keep getting thrown off on the top.
Let me share my screen here. Where's the dumb share button? There we go, share. Okay, tell me when you can see it. Can you see my screen at all?
Yep.
Okay. So this is over here. This is the bottom part basically, right? So we got our standard deviation, our sample size. This is just the square root of the sample size.
Okay.
And then that's the sample size divided by the square root.
Okay.
Right? So that's that one. So we got the same number on that one, I believe.
Yep.
So up here, now I'm doing the top part if I remember correctly. And so I've got the random variable, the mean that we figured out from down here, right? Oh, because I'm doing it. Oh, wait, I'm doing it. The way I do it is a little weird here. So, okay, so let's go like this. So so I've got my random variable minus the mean of the normally distributed value. Oh my goodness, did I make this wrong? I swear I was answering questions right. But now I'm looking at it, I'm like, wait, is that right? Hold on.
Had anybody else done this? James or Bernard?
So my understanding is when you look at that problem, your sample variable is what you're trying to compare the mean to, if that makes sense. So like with this problem, it's saying what's the probability of having a mean that's greater than the sample mean, right?
Yep.
Which the sample mean is 160.
Right. So shouldn't it be the 160 minus the mean of the overall at 150.8?
I mean, that's exactly what I'm thinking, but I think that's where I've got confused because that's how I was doing it.
Because I think that in the homework or in the chapter, the problems they give you, it's done like that. Like it asks you questions like, what's the probability of having a you know, whatever variable you're looking for higher than this number, and the examples just go in and they use that comparison between that number and the mean of the sample. So I don't know if that's right or not, but that's what I was thinking. But the problem with that is if you do that, divide it by the number that we're getting to, the 3.935, you're looking at a number that's like well over 2, which means your probability is less than like 1%.
Yeah, that's.
Which maybe that's right. I don't know.
I know, that's where I'm keep getting confused.
Well, how about we come back to it?
That's fine.
Yeah.
Let's just move on and come back to it. So question 10, what is the shape of the sampling distribution of the random variable which represents the sample mean of the 81 students who are selected?
It's approximately normal.
Yep.
Yeah.
What is the mean of the distribution of the sample means for all possible samples of size one that could be drawn from the parent population? It's 3.5, isn't it?
Yeah, it's the same as the
question.
Yeah.
I'll stop sharing here.
And what is the standard deviation of the distribution of the sample means for all possible scores of size 81 that can be drawn from the parent population?
So 9 divided by 9, whatever it is.
Sorry, what question are we on again?
12.
12, okay. I'll have to have you guys go back and give me the other ones.
Is it 0.0777778? For 12?
My calculator is being obnoxious. Hold on.
Oops, wrong one.
I got 0.077. I don't know if that's right or not.
Because that should just be standard deviation divided by the square root of the sample, right?
0.3888889. Oh, I'm looking at the wrong thing. I'm sorry. Wrong one.
Because if that's the case, it's 0.078. What I got.
Yeah, because you got around.
So you said the standard deviation over the square root of
The sample.
the sample. That's why. Okay.
Which the sample's 81, the square root of 81
Yep.
9. So
Yeah, I got the same thing.
okay.
Or what'd you guys get?
It should be 0.078 with the rounding.
Okay.
13. What is the probability that the GPA for 81 randomly selected BYU Idaho students will be less than 2.3? this is the same as the one we just skipped. So you would think if you're doing 81 randomly selected students, you'd have 81 minus your mean.
I have it only gone from lower still.
Your 81 is the square root, so we know that the bottom is 0.078.
Right.
Then if we have 3.3, that's the value that's given us. So we have to do 3.3 minus the mean, which is 3.5. So it gives you negative 0.2 divided by 0.078 gives you negative 2.5641.
So that's your z-score.
That's the z-score.
Applet.
Yeah, so then you put that in the
We're looking for less than, so it'll be to the left of it.
It's a very small probability. 0.005. 0.5%.
What did you guys get?
0.005%.
What did you get as a z-score for that?
Right. So once you find the z-score, you have to find the probability based off the z-score. So since we're looking for
Oh, that's
probability of it being less than the z-score, it's to negative 2.57.
Yeah.
Now we're looking for greater than.
Is it greater than?
Oh, there's the next question.
The next one's greater than. Okay, yeah.
Yeah. So that's just the difference between.
9.5.
0.995. Oops.
in the assignment.
Oh, this is a longer one.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 180 pounds. The previous value was lower, but was raised after a tragic boating accident. How sad. The standard deviation of the passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. Okay, so let's see. Passengers is as extreme or more extreme. Okay. So we're looking for above and below the mean. Okay, so your sample is 48.
So that'd be 3.8538 for the standard deviation of a sample mean. Is that right?
Let's see here. 26.7.
3.8538. The bottom.
Yeah, that's what I got for that too.
And then on the top, it would be 177.6 minus
Yep.
5, right?
Yep. Mm-hmm.
What was the top again? Sorry. I'll make sure I got this right.
Isn't the top 177.6 minus 185?
Yes, that's correct. So the z-score is minus 1.92. You guys have that right?
Yeah. That's what I got.
Sorry, what was that z-score?
Negative 192.
192.
Negative 192.
Negative 0.192, right? Or is it?
I got negative 1.92.
Oh, sorry.
Mm-hmm.
Yeah.
I say, I'm like, that's just kind of crazy there. Okay.
Above or below the mean?
The extremes, so are they just looking for the two ends? Is that what they're looking for? Would that be the 0.0549?
No, it's everything above.
Oh, everything above the mean.
Oh, wait. The random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean. than was observed in this-
And then note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction.
So is it everything?
Yeah, that. Is it the two extremes? Is it the two small?
That would have to be.
As extreme or more extreme?
So it would be 0.0549.
Yeah, that's what I got. Like it's
What was that again?
0.055, right, with rounding.
Yeah, that's right.
0.055.
So for 9, I did the same thing and I got 0.9966, which would be 0.99. No, because it says to round to 4 decimal places. But I have no idea if that's right.
What did you have on that one? Sorry.
0.9966.
So if you round that, it would be 9.997.
No, you have to round to 4 decimal places.
Yeah, this one's a 4.
Oh, of course it is.
So I'm going to submit and just see if we're doing this right.
What did we have for 11? I'm sorry, I was doing something on my Excel sheet when you guys did that one.
3.5.
3.5.
3.5. Okay.
Yeah.
All right.
So the ones that we got wrong were question 5, which we answered the central limit theorem.
Okay.
Okay.
Question 8, which was the random sample of 5 students, and question 9, which we just did. So I'm going to open up my second attempt. And let's work on those ones again.
So would number 5 be normal distribution then?
That would be my guess. I know it's not the law of large numbers.
Yeah. It's either the normal distribution or the 60, 90, or 68, 95, 97, 90, 97.
I don't think it's, and I don't think it's the 68, 95, 99.7 rule.
Yeah.
All right. So then we got questions 8. 8 was wrong.
And 9 was wrong.
And what did you, Austin, what did you put for 8? Do you still have that open? Did you put 1.045?
1.045.
Okay. Okay, so it's not the same. All right. 160 plus 175. I don't think I said 10 wrong, but no, I did.
So we need to find
Z-score corresponding to the sample mean.
so what's the standard deviation of that sample size? So is that when you just figure out is the standard deviation of those 5 numbers, right?
Yeah, we need to figure that out.
Okay. Whoops. 163, 149, 153. Oops, let's do formula. Standard deviation. Oops.
Should be 10.0498.
So that's the standard deviation. So then,
Sorry, what was the standard deviation?
Austin, you got 10.0498, right?
Yeah. But what throws me off on that is it tells us up above that the standard deviation is 8.8.
That what?
The standard deviation is 8.8.
Well, this is for. Well, let's just try it with both.
Oh, I know what we did.
What?
So we need to do the 160 minus the 150.8, which is 9.2, and then divide that. It should be 2.3377, I think. Because we have to do the whole big formula just like we were doing with the to get the z-score, because this has 5 students, so we do the square root of 5. So the standard deviation divided by the square root of 5, which is 3.933, and then the 160 minus 150.8, which is 9.2, divided by the you do 9.2 divided by the bottom and get 2.337. That makes sense?
Yeah.
Yeah.
But it's 2.3377, so it probably should be 2.338.
Yep.
Okay. Got it.
And then back to our favorite question.
What was the next one? Was it 9?
9.
So now we just plug the 2.338 in, and it says 0.9903 is greater.
0.9903.
Yep.
Okay. All right.
Does somebody want to submit and see if that,
Yeah, I can do it.
since we still have another try?
Yeah.
5 and 9 are wrong.
Oh, okay. So,
And actually, I guess I put in 13 wrong. What did you guys get for 13?
I got 32.4.
0.005.
Oh, okay. It's
What did you put in the box for 9?
I put 0.9903. Oh, did I take it? Wait. Yeah.
He didn't round. Oh no, it's 4 decimal places.
Yeah.
All right. Does anybody else have any idea on that?
No idea, but we've got my free Zoom account, so we're going to run out of time. So I just sent you guys another link if you want to hop back on in a second.
okay.
Just FYI. Sorry. I didn't set up a new one for this class. I just used the same one. So
You're fine.
I'm
So
gonna-
do we do large numbers, or do we do the 68, 95, 99, 7 on
I
5?
think it's large numbers, but I could be wrong.
Might as well try it, right?
Can't hurt.
Yep.
Okay, I'm gonna get on the other meetings.
Yep.
Okay. Let's get on the other meeting there.